Right, good morning, everyone. Today we're going to be covering systems of inequalities, okay? And this is going to be really similar to what we did last week with systems of equations, where you take a word problem and you basically translate it into equations. The only difference is that instead of an equal sign, right, because we're not working with equations anymore, so we're not going to have an equal anymore, we're going to have inequalities, okay? So you might remember that that's these symbols here, right? Greater than or equal to, less than or equal to. These are all the different inequality symbols. So let's start with the keywords that you're going to see in the problem. This is going to be almost like your Google Translate. This is going to tell you what symbols belong with which keywords, right? So you want to make sure that you copy this down in your notebook so that you have it as an easy reference later. All right, so make sure you pause if you need to and you copy it down. All right, let's go. First one, we have more than, okay? That means greater than. That would be this first symbol here, greater than, okay? So when you see more than in a problem or you see something that says greater than, this is the greater than symbol, okay? So I would add these notes because these are different variations of the wording that you could see in the problem. So you could see greater than, you could also see above, okay? And then if we see any others along the way, we can definitely come back and add them. So greater than is strictly more than, okay? Next one is at least. Think about it this way. If I ask you, I need you to make at least a 70 on the test in order to pass, right? You need to make at least 70% in order to pass. That means you need 70 or higher, right? If you make anything below 70, you're not passing. So when you see the word at least, you need greater than or equal to. So 70 would be included, right? 70 is still considered passing. So when you see the word at least, it means greater than or equal to, okay? Other words you could see are minimum, or you could also see it as no less than. For instance, I could tell you, you need to score no less than 70, and that means the same thing, 70 or above, okay? So that's these two keywords so far. Just a way to help you remember how the greater than symbol looks. Greater than, if you think of it as an arrow, points to the right, points to the right. And when we get to less than, you're gonna see that less than, when you think of it of an arrow, it actually points to the left. So that's an easy way to help you distinguish between the two symbols. All right, so let's move on to that. Less than. Less than means this symbol here. This is a symbol for less. Another way that you could see it in a problem, you could see the word below, or you could see fewer than, right? Just other variations of the word. When you see at most, let's say I send you to the store and I tell you, you can spend at most $50. That means $50 is your limit. You cannot go beyond $50. So when you see at most, even though it has the word most in, it actually means you need to spend less than or equal to that amount, okay? So write these other words down. Maximum, you could also see it as no more than, you can think of it as a budget or limit or spending limit. You could also see the words cannot exceed. And I don't think I spelled that right. Does it have a C? I don't know. You get the point. Cannot exceed. And then make this last note that when you have less than, if you think of it as an arrow, it points to the left. Points to the left. Points left. All right. So let's practice on a problem. We're gonna do number 1. Miss Tran, can I get you to quickly just read the problem for me?
Yes, so as I quickly read the problem, I can tell that we are talking about Eugene. And he have 2 jobs. So he worked at a car wash attendant and he also a cashier. So our variable in here is gonna be a cashier job and car wash attendant.
Okay, so our two variables, do you want to use X and Y, or do you want to use car wash and cashier?
Let's say with S and Y, so we don't have to change in later on when we graph, just like you told us the other day.
Yes, exactly. Eventually, we're going to graph on Desmos, and Desmos only accepts X or Y. So it makes it easier to just use those variables to begin with. So what would X be, Ms. Tran?
Cashier.
Cashier, or you could say cashier hours, because we're talking about the hours that Eugene is working as a cashier.
Oh, you're right, yes.
Cashier hours, and then what would Y be?
Car wash attendant hour.
Good, so I'm just gonna say car wash hours, right? So as we read this problem, Ms. Tran, we have Eugene can work at most 20 hours. So what's the keyword here?
At most 20 hours.
At most. So which inequality are we going to use?
That's going to be the less than. The less than.
Just the less than?
Oh, less than and equal to.
Less than or equal to. Good. Because at most means that he can get to 20, so it can equal 20. He just can't go beyond that. So what you guys should do is annotate the text as you go and pick your keywords and put the symbol that goes to it, right? And if you have this for reference, it's easy. The next part says he needs to earn at least $92. So Ms. Tran, what does at least mean?
At least mean like no less than. So it's a minimum. So greater than and equal to 92.
Good. So for at least, and if you see we have this keyword too, he wants to make at least $92. So that means $92 or higher. So this inequality here is going to be greater than or equal to. Then we know that his cashier job pays $7.50 per hour, and his job as a car wash attendant pays $6 per hour. So these right here are important because they are my rates for each type of job.
Okay.
And then, so now we need to write a system of inequalities. So once you get to the system, guys, remember what we told you last week? This is all about grouping the information that goes together, right? So money goes with money, and then quantities or amounts of hours, in this case, goes with numbers of hours. So let's see, Mr. Blanco, can you help me put the equations together?
Sure. So usually I will try to look for the sentences. So I will try to see if one sentence goes with one inequality. So I will look at the first one. So Jean can work at most 20 hours. So what I'm going to do is I'm going to add the hours. So I'm going to add X plus Y. And it's going to be at most. So I'm looking at I'm looking at the chart. So it's going to be less than or equal to 20.
20. Excellent. So the number less than or what is it?
That's the inequality with the hours.
Yes, exactly. Very good, Mr. Blanco. Thank you. So hours as a cashier and the hours as a car wash in total should be less than or equal to 20. Very good. Mm-hmm. Let's move on to the second equation.
So the next sentence is he needs to earn at least 92. So we need to multiply how much, I think it's a she, right? She gets paid per hour. So it's going to be 7.50 times 6. That will be for the cashier job.
Uh-huh.
And then plus, and we need to add 6 times Y. That will be how much she gets paid for the car wash job. And then it's going to be, at least. So at least is going to be minimum, no less than. So greater than or equal to 92.
92.
Because that's the minimum that she wants to get.
Yes, beautiful. Thank you, Mr. Blanco. Good job. And good job, Ms. Tran. So we are pretty much done, guys. We did what this was asking. We wrote the system of linear inequalities, right? It's still two equations, right? But they're inequalities, so they're called systems of inequalities. So now what we're gonna do to try to put it all together, we're gonna graph this on Desmos because you are actually able to graph inequalities on Desmos. So let's see what that looks like on a graph. What I'm doing is I'm just resizing my windows so you guys can see, and you guys can do this on your own too. This is a really useful tool. You just resize your window so you can see two at the same time. So if I go to Desmos and I graph this first equation, x plus y, less than or equal to. All right, so to get those inequality symbols, what you want to do is bring up your toolbar, and it's usually with a keyboard icon, and then you just pick the inequality you need from here. So I need less than or equal to 20 and press enter. Okay, that's my first equation. Now you're gonna notice that there's some shading going on, and it looks like everything is shaded, everything is colored in, okay? And the reason for that is that we're so zoomed in that we can only see a little bit of the graph. So remember that you can always play with the zoom, you can always zoom out, or you can zoom in to adjust it to where you can make sense of what it actually looks like. So see, I can actually see the line now, and it looks like the shading is below the graph or underneath the graph. So that's when I graph that first inequality. But I not only have one, I have two. So the next one is 7.50x plus 6y. And now I need greater than or equal to. So let me pick that inequality from my list down here. And that should be greater than or equal to 92. And enter. All right. So Mr. Yomoa, tell me what you notice. What do you observe after I graph the second equation? Let me zoom in.
Yes, I can see different ranges with different colors. I can see the blue color at the top, and below one of the graph, I can see like orange, if I'm right with my colors. Then I can see also an overlapping region.
Ah.
Yeah, it's that one. I can't tell it's a color of blue plus the orange. And I don't know the answer for blue plus orange, but that is an overlapping region.
Yes, you're exactly right, Mr. Yomoa. Good job. So let me erase the second equation that I graphed just so that you can see it. Right now, the first equation is the red line or the orange looking line with the shading underneath the line, right? Mm-hmm. And when I add the second equation, it adds this blue line, and the blue line is shaded above the line, okay? And as you observed, there's this small region where the two shadings are basically overlapping. So it creates a third color that's like in between a blue and an orange. Exactly. So this overlap in coloring, that's basically our solution, guys. Because you might remember from systems of equations, you're looking for the value of x and y that makes the equation true, right? It makes both equations true. So in this case, your solutions is demonstrated by the overlapping, because the overlap means you're meeting the requirements for equation 1 and also equation 2. So the overlap satisfies both equations at the same time. Okay, so Mr. Yomoa, excellent job. So now that you know that this region here is our region of solutions, can you tell me a possible point or a possible combination of X and Y, cashier hours and car wash hours, that Eugene could work to be able to meet both conditions?
Well,
let me zoom in.
Because of the, if you look at, I mean, because of the scale of the graph, it is a little bit difficult. But however, when it was at a larger scale, I saw, when it was at a larger scale, I saw when X is 150 and Y is negative Y 150.
So you want me to zoom out?
Yeah, if you zoom out, you see 150 and negative 150.
Okay.
But do we have negative 150 as hours or anything?
Yeah, you're exactly right. Would that make sense? Could I work negative 150 hours? You tell me, Mr. Yomoa, can we work negative 150 hours at a car wash?
No, I don't think so.
Yeah,
You
so
cannot.
you bring up a really good point. So this graph is basically a theoretical graph that just shows us all possibilities that includes positive and negative numbers. But because this is a real world situation, we only need to, which quadrant do we need to look at only, Mr. Yomo, so that the numbers make sense?
Well, to make sense, I think we have to look at the first quadrant, which is on the top right.
Excellent. So I really need to look at this region here because it doesn't make sense for us to talk about negative hours or negative money. Excellent. So then in this region, can you give me 1 point that's in the overlapping?
Okay, with that being said, then it means that when x is 10 and when y is 5,
okay,
we satisfy the overlapping region.
Excellent. So when x is 10 and y is 5, it satisfies the overlapping. Good. And is that the only point that's a solution?
I think there are many of them, but that's where that's what I can see and what I would like to say. But
yes.
There are many of them. There are more than one.
Yes, exactly. Any point, I could choose 15 and 3, 15 and 4. So there's a lot of possible solution points now, but right now we only need to identify one. And we just need to know that it needs to be in the overlap.
Ms. Perez.
Yes, sir.
Did those possible solutions, do they only have to be in the overlapping region or they can be at the overlapping boundaries?
So are you asking, can it be on the line?
Yes.
Excellent question. Yes, as long as the line is solid, it's part of the solution.
Oh, okay.
If the line was a dashed line, then it wouldn't be.
Okay.
Great question.
But are they solid?
Huh?
Are they solid?
Yeah, because you don't see any broken parts of the line, right? And also, if you look at the inequality, they're equal to, so that means the line would be included.
Okay.
Yeah.
So that's solid.
Awesome. Great connection there, Mr. Yomoa. GT. All right. So let me write down the point that Mr. Yomoa gave me. Remind me what it was, Mr. Yomoa. Was it 10 and 5?
10 and 5, yes.
And this is one possible solution point. And then I'm just gonna make a note that that is in the overlap of the shading in the graphs. Perfect job. Does anybody have any questions about this? Going once, going twice?
I have a quick question to show you the answer when I submit the assignment. You want me to give you like some points, or you want me to take like a screenshot of the graph on this?
Just set up the equations for me, because this is actually the only thing that the question is asking. If it asks you for a possible solution point, then that's when you need to go graph and look for the overlap. So you need to double check what the question is asking. Is it just asking you to set up, or is it actually asking you for one possible solution?
Thank you.
You're welcome. Thank you for asking. All right, let's move on to number 4. So 2 and 3 work very similar to number 1. So I'm going to leave that for you guys to work out on your own. We're going to go ahead and try number 4. Okay. So I'm going to quickly read this for you. Jennifer is having a cookout and plans to serve steak and barbecue ribs. She has budgeted a maximum of $120 for the meat. Steak sells for $7.99 per pound, and barbecue ribs sell for $5.99 per pound. She plans to buy at least 3 times as much steak as barbecue ribs. Write a system of inequalities to represent the amount of steak and barbecue ribs she can buy. Oh man, Jennifer's gonna have a fancy barbecue because steak and barbecue ribs are expensive. So hopefully we're invited, guys. I hope Jennifer invites us to the cookout.
Let's go.
All right, so Ms. Doe, now that we read the problem, can you help me go back and reread so we can start picking out our keywords?
Yes, our keyword will be maximum.
Maximum.
On the second sentence.
What does that mean, Ms. Doe?
Maximum means you have to go no more than that. It's the limit, so you have to go less than and equal to.
Excellent. So that means less than or equal to?
120, yeah.
And then any other keywords that you can pick out so far?
Yes, she plans to buy at least 3 times as much as steak as ribs. So at least is greater than or equal to.
At least, good. At least means greater than or equal to. Okay, I like that. And then this information goes with 3 times as much steak as barbecue ribs. So
Yes.
what does this here mean, Ms. Doe? When we see
So
3
it means steak is more than ribs 3 times.
Okay, steak is more than ribs by 3 times. Excellent. So we know we're going to be multiplying times 3, and it's the steak that's going to be 3 times as much as the barbecue ribs. All right, so we'll get to that here in a second, but good job. Thank you, Ms. Doe. Also then, what are we looking for? What would be our variables?
A variable is steak and barbecue ribs.
Good. So are you okay? We use X and Y?
Yes.
X equals
amount of steak.
And Y would be?
The barbecue ribs. The pounds.
Right, and we know we're looking for pounds.
Yes.
Excellent. Thank you so much. All right, so then Mr. Barclay, now that we've kind of gone through and defined our variables and we have the keywords, can you help me put the equations together?
Yes. Okay, let's start first with our first line. Bits of information there was regarding money. So let's put together our money line first. Since steak is $7.99 per pound and steak is represented by the letter X, let's put 7.99X. And we're adding that to the barbecue ribs, which is $5.99 a pound and represented by Y. So we have a plus there. And the most that she can spend is $120. She can spend less than that. So let's do less than or equal to 120.
Very good. I like it. And that makes perfect sense. And you stated it very well, Mr. Barclay. Thank you.
Thank you.
Can you help me out with the second equation now?
Yes, the second clue that we have is her plans, which is to buy at least. All right, at least. So anytime we hear the words at least, that tells me that's the bottom number. We can go greater than or equal to. So she plans to buy at least 3 times as much steak as barbecue ribs. So we need our sentence to balance out. All right, so steak stands alone. So we got X is going to be greater than or equal to 3Y. So 3 times the barbecue ribs would equal the X, right? 3Y.
Right. So then our final inequality here would be X is
greater than or equal to
3Y. Excellent. Very good. Thank you, Mr. Barclay. Beautifully stated, by the way.
Thank you.
All right. So even though it doesn't ask me, technically, once I write the equations, I'm done, guys, because that's what the question is asking me. But we still want to practice our graphing on Desmo. So I'm going to go on here really quick, and I'm going to graph those 2 equations so you guys can see what it looks like. Every time I go back to Desmos on a new problem, I like to refresh, because in the earlier problem, I kind of changed the window and the range of the zoom. So I always like to go back to the standard window, okay? And then I can adjust from there for my new problem. So I have 799x plus 5.99y less than or equal to, all right, so let me see my inequalities, less than or equal to 120. And then x is greater than or equal to 3y. So let me maximize that. Zoom out just a bit. All right, so you guys see how now we have a red line with the shading underneath, and we have a blue line with the shading underneath, right? So then our solution region is this weird blue-purple overlap. And again, we really only need to look at the first quadrant, because we can't have negative pounds of steak or negative pounds of barbecue ribs. So that means that our solution region is this triangle right here, right? So any point in this double shaded triangle would be a possible solution. So I could say, I'm going to pick a point for us, 10 and 2. 10 and 2. So one possible combination of meat that, Jennifer could buy is 10 pounds of steak and 2 pounds of barbecue ribs, right? That's one possible combination of pounds of meat to meet both conditions. So looking at the overlap. Any questions about that? Somebody here in the chat. Oh, Ms. Doe, thank you. Another possible combination is 12-2. So let me pull up the graph again. 12-2 over 12 up. Yep, that's another, because that point is still in the overlap. Can anybody else send me another possibility in the chat? Other combinations that would work?
1 and 6.
1 and 6. Thank you. So let's see. Over. So 1 would be here. Wait, who said that?
A second one. My bad. I'm confused between X and Y.
Oh, gotcha. No worries. So if I check that 1 and 6, that would be this point here, and that's only in the red region. So that would not meet both conditions. But if we use 6 and 1, then that would work. Good job. Thank you, Ms. Tran. Mr. Juani, 9-1. So over 9 up 1, that works also. Ms. Dallas, 8-1. Excellent. So lots of possible points that could work. So we'll stop here, and we have one more example to do, and then we're done. Okay, so just bear with me. We're almost through. I'm gonna leave 5 and 6 for you all to do by yourself. And I'm gonna go all the way to number 7, okay? You might wanna really put a star by this, because you're probably gonna see a similar problem to this later, hint, hint. All right, so let's get started. Ms. Dallas, can you please read the problem for us and help us pick out the keywords?
Okay, the problem says the rectangular patio shown in the diagram below is enclosed on 3 sides by a fence. The area of this patio is no more than 400 square feet. The total length of the 3 sides of this fence is no more than 60 feet, which system of inequalities can be used to find values of L, the patio's length, and W, the patio's width. That will satisfy these conditions.
Awesome. Thank you, Ms. Dallas. So as you read through that problem, did you pick out any keywords that are going to help us set up the equation or the inequalities? Sorry.
Yes. I'm going by sentence. The first sentence, it says no more than 400 square feet. No more than.
So then what inequality would we need to use for that?
Greater than or equal to.
All right. So think about what greater than
No,
means.
less than or equal to. I'm sorry.
Yeah. So the emphasis is on no more than, right?
Yes.
So it's kind of tricky. So that's why it's useful to keep our notes nearby. So then what does no more mean again?
Not less than not greater than 400.
Okay. So what would be the inequality?
It will be the L one.
L1, because it actually needs to be that or less.
Like 400, yes.
Mm-hmm. Less than or equal to. Perfect. And then next sentence.
The total length of the 3 sides of this fence is no more than 60 feet.
No more than.
Same thing.
Same thing. Same keyword.
Yes.
Less than or equal to. Can't really see that. Anything else?
Well, I think that's it. That's it. Yes.
All right. And then in this case, it tells us what variables to use. L for length, W for width. So no need to use
Instead of X and Y.
Exact. Good. And also, what are we looking at for the patio, Ms. Dallas? What does it say? Are we looking for its color, its size, the area, the perimeter? What are we actually looking at?
The values, the possible values of the length and the width of the area of the patio.
Okay, we're looking for the possible length and width for the patio For the dimensions of the patio. Okay, perfect. Thank you, Ms. Dallas. So now let me switch gears and call on Mr. Alcarcas. Can you help me out with the equations?
All right. So the first one, length and width. Let me see. Patio is no more than 400. So LW.
Let me backtrack for a second.
Yeah,
It's talking about the area, right? So here we need to keep in mind how we find the area of a rectangular figure.
Length width. LW.
Yeah. We know that area equals length times width.
And that is less than or equal to 400.
Okay, so then how do I set up my first equation?
LW.
LW.
Okay. Less than or equal to 400.
Perfect. Very good, Mr. Alcarcas. Thank you. So that's from the first sentence, right? What's the next part?
Let's say it says the total length of the three sides. Okay, three sides that we have one L marked L on the graph, and it would be two W's. Okay, so L plus 2W is going to be less than 60, less than or equal to 60.
L plus 2W is?
Less than or equal to 60.
60. By the way, excellent catch, Mr. Alcarcas, that it's only one L and two W's, right? Can you tell us how you know that?
From the diagram, the sketch.
All right, so
the house, the other length, okay, opposite, is already built aside of the house. Okay,
yes.
So we only need the three sides. We're if we are building this, we're just building three.
Yes, absolutely right. So the only part that we are enclosing is the outside part. That's
the dashed line.
To the house. Yep. So we're looking at the dashed line. Yeah, very good. So that's why we have two W's and only one L, and that has to be less than or equal to 60, according to what the problem says. Excellent. Thank you, Mr. Alcarcas. So now that we wrote our equations based on the information given in the problem, it's a matching game, right? Which of the answer choices matches exactly with the equations we wrote?
Okay, so the last part is, so we're not confused, just look at the LW less than or equal to 400, and you can see that C and D we can just rule out just based on the LW less than 400, because the C and the D, the LW is greater than or equal to 400. So we can rule those two out right away. Now let's go over to A and B and just look at that one. L times W is less than or equal to 400. So we have A and B both the same. So now we're going to look at the second equation and then make our decision based on it. So the second equation is L plus 2W less than or equal to 60. Which one matches? Well, based on our information in A and B, we can just rule out B and circle A.
Right, because you don't have two lengths, right?
Right.
Excellent. So final answer here is A. So just to emphasize to everybody on this part that the answer choices always look very, very similar. So you need to be smarter than the question and make sure that you are paying attention to the detail, right? The devil's in the details. So don't accidentally pick the wrong answer choice just because you rushed through just picking one that looks right. Hope you guys can get through the rest of these problems. If you all need help, just let us know. We're here to help you.